Well, I'm personally very excited about this portion of the workshop. Yeah, especially stage is really cozy. We'll see about the questions. So throughout the workshop, we talked about the limitations of understanding and reasoning for LLMs about the world. The first question I want to pose is, okay, so this is the capabilities and there are a lot of problems now, but how do you foresee the evolution of these reasoning capabilities in the next 3 to 5 years? Any takers?
Yeah, since my whole talk was that they can't reason, I don't foresee too much as of now. I think it's basically a question of whatever is an approximate retrieval from the knowledge that have been, the text or the knowledge that have been trained on. So there are very easy ways right now of showing that they can't reason, but it will become increasingly harder because when you have encyclopedic knowledge, showing that you don't reason becomes extremely hard. You have to come up with diagonalization arguments. And so at some point in time, we'll give up and they'll say, yeah, how can you tell the difference whether they're reasoning or not? Because we actually get by in real world, I think, most of the time without having to do first principles reasoning. And I don't know how many of you still do fx plus h minus fx by h tends to 0 as the way to do derivation, derivatives, right? And so we mostly just get by with the approximate retrieval. But once in a while, when we get stuck, that's when the quote-unquote integration B is when you will get seen that you're without the cart without pants, sort of thing. So I think it becomes harder to show that they're faking reasoning, but currently it's quite easy to show that they're faking reasoning and then I think we are ready to delude ourselves when I think one of the interesting things that this morning talk by Guy, as he points out, it's not obvious that every test set, doing well on a test set actually tells you anything about reasoning because there are many, many different ways of constructing test sets. So I guess I think that doesn't necessarily mean that it's a hopeless thing because they are great sources of approximate knowledge. Mm-hmm. They're not sources of reasoning, and so you can use them for that.
I would say, first of all, I would not restrict the question to LLMs. I know LLMs are very hot these days, but we are all researchers and we're looking and exploring left and right. So I'm not sure that in 3 years we're going to even talk about LLMs. But we are still going to try to find solutions to reasoning tasks, and I think that's the most important part. It's not the model that we use, it's the approaches that we're going to explore and the limitations that we know. Today, we know a lot of the limitations that makes reasoning hard. I think that's great for us researchers because it's a good playground. If people search, I think they are going to find advances. On my side, I do believe that some solution will probably come from a better modeling of either loss functions or regularizer that encode some of the things that we humans do when we are able to solve these reasoning tasks. I don't know yet what they are, but I can see many options. So I am optimistic. Otherwise, I wouldn't be here.
Yeah, I would say, even though my talk this morning was a little bit negative about the logical reasoning capabilities for large language models, I do think we will find better ways than prompting to use these models to extract all the common sense knowledge in there. And there's so much that is in language about affordances in the world and common sense scenarios that we're not really properly accessing. We're just begging the model through prompts to tell us something about the real world. And we'll definitely find better ways of extracting that knowledge as some kind of soft, very large fake knowledge graph. And that's also reasoning. Now that being said, I don't really think that this purely data-driven approach where you have no sense of any algorithms will really lead to any serious long-term deductive reasoning that we all hope to achieve. And so I think then some neurosymbolic approaches will really move the needle in that specific type of reasoning. So it's kind of a mixed bag for me.
Yeah, so I think one thing I'll add on a little bit is that I think it came up in some of the responses already that it's a little different. Even humans, we get by with a lot of heuristic reasoning in a large number of domains, and it's arguable that what we think of as formal reasoning only comes out of very specific kinds of training. That you have access to specific kinds of education or feedback-based explanations, things that our society has built this whole framework to help us learn how to do this kind of reasoning, but arguably it only comes out of this kind of formal education. And I don't think we quite have that equivalent for language models yet, so I don't want to write them off completely yet, like in the sense that this ability to actively explore things and get feedback on what they did wrong, things like that. Like given that they have semantic grounding, many of these things are now accessible where you can basically think about more intelligent ways to educate systems rather than just asking them to predict the next token. So just in the, extending RLHF to more, rather than just saying this was a good response, this was a bad response, I think there's just a lot of things that could be done in that space that mimic the kinds of things that help humans do better kinds of reasoning, and that's a sort of interesting direction.
So I have two opinions. So I think for first one is similar to what other panelists has mentioned before. So because on certain problems, it's difficult to differentiate between retrieval and reasoning. So possibly that in the near future, we will see their abilities continuously to grow just because maybe the training set becomes larger or people prepared certain data sets which is able to induce certain reasoning behavior. So a second thought is that when we talk about reasoning, it's a very broad term, and it can be helpful for researchers to maybe find some systematic way to characterize the reasoning behavior you are trying to work on. And so for certain behaviors at certain complexity, maybe we will see more breakthrough compared to some other space.
I think, all right. Just share the microphone. Yeah. So we have some mixed opinions, but Victoria's point sort of brings me to the next question about more concretely defining reasoning, because reasoning is a broad term. Can we, provide some more mathematical or concrete definitions that'll guide us understand this reasoning better? So, more concretely, we've been relying on a bunch of downstream tasks such as QA, summarization, etc., and more recently automated evals with different LLMs to measure the performance of language models. Do you think we can measure reasoning, whatever that means to you, capabilities in the upstream, by upstream meaning during pre-training the models perhaps moving forward?
So some thoughts related to marrying reasoning or characterize it. So I believe there are certain data sets nowadays being proposed. So for example, trying to probe the reasoning capability of language models. So I think those can be an interesting start. So for example, I can possibly give a shout out to some of the work I collaborated on. So which is a data set recently proposed called Folio, which is testing first order reasoning capabilities of language models. So I think probing data sets can be helpful in some sense, but on the other hand, they also have some limitations like real world problems. How do you connect them with systematically designed those example probing data sets? So those are some challenges to solve. So how to connect certain behavior you are mirroring with some real world problems.
Yeah, and I think I'll go back a little to the formal education point I was making for the previous talk as well, for the previous question as well, that currently most of the training data that we have is just web crawled data, which doesn't contain interesting kinds of reasoning. So just having, and I think there's already results from various findings that things like training on code improves things like compositional generalization of these models. Even just training on textbooks that are, higher education textbooks. So that kind of data is hard to extract, but there are people working on it, and they just haven't made it into the training data sets of most of the language models. So if we include, it feels like at least worth trying, right? Like making sure that if you're including all of the kinds of data that we as postgraduate people who are judging what logical reasoning looks like should make sure that the models actually have access to the same data. So even building out the training data sets to include more complicated forms of things that aren't just news articles and written for the public, but written for people who actually do this kind of reasoning.
It's a tough one. I think we're all stuck on this problem. And to be honest, as someone who's more on the algorithm side, I see a lot of tweets and a lot of papers fly by, and then I think to myself, do I know how I would evaluate such an approach? Would I, if this was my paper, would I trust that it's doing something? And very often I have no idea, and then I also tend to sometimes ignore the research, which I'm sure is great, just because I don't think any of us really know how to evaluate what we're doing at the moment. And I think I don't really have any answers there. Of course, there are certain approaches that actually do formal reasoning guided by language models, neural networks, and there, they always do the right thing. No one's questioning that, Rao's planning algorithms actually find the optimal plan. They do provably. And so maybe we should kind of step away a little bit from this kind of test set evaluation mindset when we talk about reasoning. But I don't have the answer.
Maybe as a start, we should start from realizing that we're in some kind of bad local optimum where we have these very large models that are trained by others, and you don't know what the data precisely they use to train these models, and you use them then to fine-tune maybe, or then evaluate whatever task you have in mind, but you don't really know what capabilities come from the fact that some of the data was already available in the training set, because this is not known to you. So you try to come up with tasks that you are almost sure that it was not in the training set. This is hard. The first step is to recognize that currently whatever we evaluate is a bit fishy, because we don't know what the data was used to train our models. So if we could get into a state where we know better and we control better what's in the training set, we may have a chance to think of tasks that really would be testing whatever we want. In terms of reasoning, I think for me, reasoning tasks are usually manipulations of a lot of symbols, which end up being combinatorial by nature. And so these tasks, if you design them well, it will be very unlikely that they are in the training set, because there's an exponential number of these examples that exist if you design well the task. And so that makes it easier to evaluate, because you're more sure that indeed there was no chance that was in the data. But tasks that are more of the type text, like Q&A, are very likely to be somehow or very similar to others that are in the training set. So I would be careful about this kind of task.
So first of all, let's just recognize that testing whether somebody is doing reasoning by looking just at their answer is a sort of a losing proposition. I give exams to test whether my students can reason. I give them true-false statements. They can always guess true-false. The question, and then I ask true-false with justification. And it's the justification that carries the weight. And it's much harder, that would be harder to cheat. Guessing the answer correctly could oftentimes be done on approximate retrieval. And as Sammy was saying, we have no real clue. I mean, none of us have any clue as to what is out there on the web. And so this whole idea that somehow we can make up for data set contamination is just, it's kind of a losing battle, and it becomes very hard to come up with new test cases that probably can't just, the answers aren't already present in some question bank. I keep thinking that the reason GPT-4 does so damn well on the standardized tests is because all standardized tests have standardized question banks. And they're all basically for LLMs, and you have to take that into consideration. The other thing that in terms of benchmarks, people set up these benchmarks, and oftentimes we take them at face value, saying they say reasoning benchmark, and we need to be a lot more critical. I agree to be an area chair for the benchmark session thing for New York, exactly for this reason. Because the other day I saw some paper which said we actually do n-stack blocks planning. I was very impressed finally that somebody is actually at least figuring out how to do n-stacks. And I went and looked at the like the appendix 95th page or something. You find that they essentially put n-1 blocks on the right configuration, and the nth block has to be put on the top. That's not actually telling you whether or not something can figure out how to do reasoning. So you should be a lot more skeptical about benchmarks. And then last point, I think with respect to Ishita, that's actually very much on point. The reason LLMs can do what they're doing is because the data exists. We taught each other. Basically, whatever we told each other is on the web, and that basically became fodder to LLMs. The one thing we did not do as much is the way we make mistakes and finally come to the correct answer. Oftentimes the derivational trace of a solution is almost as important in understanding reasoning as what the correct answer is. Nobody actually just learns to prepare for exam by just looking at the correct answers. They have to actually look at what are the missteps that you can make and so on. And that's one type of data that's not easily available. And and as OpenAI is finding out, billions down the sink, that the data that's not on the web, if you have to actually pay somebody to prepare that for you, it costs a whole lot. And so you have to ask yourself, well, that's a reasonable way to actually just make that sort of training, where you get these derivational traces. And one very last point, from the previous question, I do want us to remember that much of the discussion is about LLMs. Learning to reason is very much possible. Reinforcement learning does learning to reason. Okay, so it's not that we're not talking about whether you can learn to reason. We're talking mostly about whether LLMs can reason. For the other part, of course, Sammy's points are very well taken.
I think 2 points really resonate with me. The first one, we don't really know what is in the training set of these models. So hopefully in the coming months or maybe a year, we will have more access into what goes on in the training sets of some of these models. And
actually, those of you who remember the Vinograd schemas became part of the training set. And so then they are not Vinograd schemas anymore. They are just approximate retrieval of what Ernie Davis spent tons and tons of time coming up with. So any of you who are professors, and I think they're more on this side and that side, you know that coming up with questions that actually force people to do reasoning when they have access to course heroes is the hard part of being a teacher. And LLM has not only access to course hero, but the entire damn web. And so it becomes much, much harder to actually check whether they're actually doing reasoning from first principles.
yeah, please.
Yeah, absolutely. One thing that I didn't come up as much, I'm not an expert on this, but I feel like maybe there's a nugget of something there. Of I'm curious about whether, even just being able to detect whether information is being derived from first principles or retrieved, is there any scope for things like mechanistic interpretability to help with that? What are the mechanisms that the system is actually using? I don't know how far along those approaches are. I'm not terribly familiar with them yet, but I'm hoping to learn more. But I think there's just in terms of, instead of looking at external behavior, can we get a higher dimension, instead of getting it to produce an explanation on its own? Because we know that self-report, even in humans, sometimes can be a bit bad, but probably still better than a final answer. But where the information is actually coming from within the system, I don't know, maybe that's we haven't been terribly successful doing it with much simpler models, so I don't know if it might be quite a bit harder to do with the very large transformer models, but there might be something there.
Yeah, I agree that one thing that's been brought up by multiple people is that we should probably move away from just checking the final answer. We should look into the reasoning chains. If they're making mistakes, there are good examples to include in the pre-training and understand the reasoning behavior. And if not, maybe they're simply retrieved from somewhere, and we can reason more about the reasoning. Okay, so this one is a little more language model specific, so you can skip the question if you want to. What do you think might be the next big breakthrough we might expect from LLMs? Like, a lot of the folks are thinking about longer and effective contexts. A lot of people are looking into that. And of course, like, you know, like these, as we all know, these models require a lot of GPUs to train. So like, can we have smaller models with the same capabilities? Like, these seem to be the like main stuff that people are focusing on, but maybe there's something else that's missing, and, you know, more people should be working on this.
Making prediction about the future is much harder than about the past. So whatever I'm going to say, there's a very high likelihood that it's not going to work. But nevertheless, I can try to give you some idea of what I'm thinking now. I can give you at least two. One is, I think these models today are lacking some more principled variable computation time. So you'd like these models to be able to use more computation when the problem is hard. And this is often the case for reasoning tasks, that they might be more or less hard depending on the problems. And today, this is somehow controlled by the size of the prompt. It's kind of cheating to do it like that, but it does work. But that's not really a principle, because you fix it yourself. So it's like you're saying, okay, now reason for that amount of steps. Instead, you'd like the model to decide that. A second line of attack would be to have more modular approaches in general. And we know that this works. For instance, we know GPT-4 is somehow an ensemble, but I think ensembles are the weakest part of being modular. So that there are many better approaches that you can think of that will be useful for many things. Now, as I said, most of that is likely wrong.
Yeah, it would also be a bad idea for me to predict the future, but I am kind of encouraged by state space models and seeing that there are other ways of wiring these networks up that kind of perform as well, hopefully. I don't know. And so I'm quite hopeful that, just, recurrent networks are not good enough, fine, but it doesn't mean that we're stuck with this one architecture that's not a recurrent neural network. And, just this kind of brute force way of just throwing attention everywhere, I feel like we can probably do better in the next 5 years and come up with something that maybe has nicer properties in some way. And selfishly, I'm kind of hoping, because I work on tractable degenerative models, that they might become as good as fitting the data while having more capabilities. The slide doesn't say same size, more capabilities, but that's kind of what I'm hoping for. We'll see how that goes.
Yeah, so first of all, I think we should agree that approximate retrieval is amazingly useful, and to the point, approximate retrieval, when you are in the loop and you get the rightish answer and you know whether or not you can tell whether it's the right answer, their context certainly helps, but context like this not at all. I don't see how it's going to help in terms of whether or not the underlying mechanism is doing any reasoning of any kind. I do definitely think that LLM modulo is basically a great, certainly short term. Again, this stuff is moving so fast that, we should be talking probably about next week, not, 5 years from now. And I think that essentially there's nothing at all wrong with idea generators when they basically are just generate ideas. They don't take any, ownership of it if it's wrong. And so we all have people in our lives who are great idea generators. We go to them, we take their ideas, and then we actually do the hard work of checking whether or not that will work for us. And LLMs are great idea generators. In the context of first principles reasoners, in a LLM modulo solving, they could be very useful. And you could do this either as a disjoint one, decoupled one, or putting them together. Late Marvin Minsky said, all of intelligence is taking the test part of generate, test, debug into generate part. And so in some sense, if you can get the test part and back into, it's not going to be just LLM architecture. There is no real reason why that has to be the case. I mean, I sometimes think that the whole times I saw there's this t-shirt saying 25 years of research into programming languages and C++ is the result and question mark. And similarly, somehow we are into LLM architecture as the only one because it's working, but obviously the other types of architectures have been looked at. And some of those might wind up being more useful in connecting the reasoners into the LLM architectures. And that would be something that I would think might work, but who knows?
So maybe like I'm not predicting next breakthroughs, but like basically some places where it might need the field to put more attention. So I think one is connecting to the previous question, so related to, so these models are trained on lots of web data, so we don't know what it's trained at. It's very difficult to get test sets which does not overlap with their training data. So I think these actually make a lot of practical use cases for large language models very important. And because like whenever you apply large language models to a particular problem your company is trying to solve, usually the scenario will be very different from just like what the model saw on the web. And we heard more about like people who work in the production like complaining about how these models break whenever they try to apply it to the real world problem. So there could be possibly be some like real progress like in near future where like people actually try to make these models practically working for certain scenarios. So, and I think the second point is I personally feel long context is a very interesting area which has already attracted lots of attention because I think for humans, we are not necessarily bounded by a window of like 2,000 tokens for our reasoning and whatever problem-solving skills. And maybe like solving long context is not by just elongating the transformer context. Maybe that is solving by some new architectures, but could potentially be something interesting to look into.
Yeah, I think a lot of the stuff has already been covered. I'll just say one small thing of like, even like inference of these models are really big, so it's starting to become, I think, a bit of a bottleneck. So I think there'll be a lot of work on sparsifying these models, making them easier to run. So I'm sort of curious about how that will influence their abilities and whether that will push towards modularizing them into separate components, whether distillation will actually work. I think it's hard to tell what will happen or not, but I think there's definitely going to be a push towards smaller models or at least fewer weights, or sparser, or models with less, the number of bits used to represent their weights being lower and things like that. So I'm just sort of, that I think is definitely going to happen because it's becoming very expensive. So I'm just curious about how that will result in changes in its abilities and how that might inform what the best next way to include complicated abilities like reasoning might be.
So like few great points to like point out, like highly recommend checking out statespace-based models. I also think they can be pretty interesting. And also the other thing mentioned was thinking of it as like an idea generator. And the analogy that was used in the talk was your annoying uncle who you can just go to but pick the right ideas from. And also the other thing that I thought that was interesting in the conference was Jennifer Doudna's talk on Wednesday. That sort of relates to Victoria's point about like if you haven't seen the data in your task and you have to deal with it, say for like structured prediction or CRISPR style tasks, we just need to generate the right kind of data. They're currently not great at this. I'll move on to the next question. So people talk a lot about the quote-unquote like knowledge cutoff in language models, right? Like they say, oh, like this has been trained until 2021, so it doesn't know, etc. But in dynamic fields where new information arises continuously, this poses interesting challenges. How do you think about this problem? Again, like it doesn't have to be like language model specific, but like what should be our strategies in place to keep these models that we're training that does reasoning, doesn't have to be LLM, or it can be LLM, updated without retraining or like without using the current methods.
So maybe I can just give it a start. So in terms of solving the cutoff and supplementing the language model up-to-date knowledge, so there is I wouldn't say mature, but has been used, a methodology has been used, which is like combining large language models with retrieval. So like if we think about the new Bing search engine, so whatever's happened in the world, like the language model should be able to propose a query and get like the relevant information from the internet, and then digesting those information to synthesize its answer. So like I think that's like just something quickly come to my mind.
Yeah, I think maybe also related to the previous point you made about long context and things like that, that like a lot of the information, it feels like retrieving from the context and retrieving from the weights are the only two options that are currently available. So just allowing it to, because even like being able to separate out information and the ability to get information, because even all humans also don't have the latest news, but we just have the ability to gather that information. But I do think that there's some, apart from augmenting things with tools, I think there's still going to be some innovation required at the level of like this middle ground of like, you can sort of, if I gather a new piece of information, it doesn't just become this one isolated piece of information, it updates how I see other things, and it's like some way to integrate that with the rest of my information. I think that requires a little bit of innovation without fully retraining it in that context. I don't know how to there's a way to just say that this is one piece of information I have, but how to integrate it with the rest of my information, I don't really know what the analog will be for moving forward.
Yeah, I think already some great answers are given for when the knowledge cutoff is a couple of years ago, but I kind of always wonder, what if the knowledge cutoff is today, which is always the case? Every time I see, there's a new generative model for generating Kanye songs or South Park episodes, I'm always wondering, if you train a generative model on paintings before, 150 years ago, would it invent Impressionism? Would it invent jazz, rap music? Right, so I'm always wondering, even when we don't talk about reasoning, we also kind of want our generative models to somehow be creative and extrapolate beyond what they've seen, which is today's knowledge cutoff. And, okay, we care about this in reasoning because reasoning, deductive reasoning is about extrapolation to out of distribution problems. But this is not exclusively a reasoning problem. Even in creative generation, there is this issue where we really want more from our models than just, infinitely many Kanye songs, right? So, yeah.
I think first the line of attack through augmented retrieval model, I think is good. More generally, you want to have a model that is modular, where there is a part of the model that is good at interacting and writing sound sentences, and you want other parts of the model that encodes some knowledge. It doesn't need to be external. It could be another module. It could be 10 other modules, but they are good at encoding some part of the knowledge in some way. Having it modular and not 10, maybe 1,000 of them, might make them much more easy to update quickly, and we could do that during the day, actually, because then we know which ones to update, and it's not 1 trillion parameter to update. But there are many challenges to get there, of course.
So I guess the knowledge cutoff is more important if you're talking about whether they're retrieving the right stuff. That's context specific and something that's obviously knowledge cutoff would matter. I would ask us to remember that it's not the stuff that is not happened that I'm worried about LLMs not knowing about, but it's the stuff that actually happened, such as we know how to do addition, we know how to do Davis-Putnam procedure, we know how to do lots and lots of things, and they obviously don't use that. And so from the reasoning perspective, this is kind of a different aspect issue. It does matter in one weird way, which is as things keep increasing, as you keep putting more and more data. I mean, in fact, any question today will become question bank tomorrow, and so that might also come back into this issue of whether or not they need to do reasoning, are they able to do reasoning, etc., because they would be able to get it from that person. But otherwise, it's basically, yeah, if your base facts change, modus ponens is not going to change because base facts change. If base facts change, then you are able to get more things, obviously.
So my last question is about integrating more accountability and transparency into AI and language models. Like, how can we ensure these models can explain their processes in a way that humans can understand and judge for fairness and ethics?
My biggest nightmare is this is how GDPR will die. GDPR, those of you who haven't kept track, basically says you get to have an explanation for the decision that was made about your loan application or anything about your life. And so then you say, give me an explanation. And if there's an LLM, it will provide you a nice, beautiful form explanation, which has nothing whatsoever to do, doesn't have to have anything to do with its actual reasoning. And so I think just explanation in itself is not going to help providing any kind of guarantee of reasoning. If in fact, we do this, by the way. I mean, we do random stuff and then we are coming with extremely good explanations as to why that random stuff, if it actually works. We know all the chess people who win the game will somehow say, yeah, I was able to see this beautiful move in the following reason, even though if it was actually might have been a particularly fluke thing. The other thing about transparency, based on your question is, I think 5 years from now, we would look back at RLHF and say, are we crazy? This is how we were trying to teach a machine what our preferences are. It's an extremely, extremely slow and extremely inefficient and extremely no guarantees process. It's the only show in town, so I'm very happy. I mean, I was able to, I'm sure the day Ford got his first car, it has all sorts of problems and people still use those cars, and then Japanese did much better job and nobody is using Fords, but that, I think we will probably look back at RLHF and say, if that's our best idea for teaching machines, this is not how we tell our kids how to, behave, for example. And I think there is a lot of work that needs to be done there. That's the currently best idea. I think we should, try to go with it, but I hope 5 years from now, yeah, I'm really hoping that we'll look back and say, oh my God, this was our best idea for teaching how our preferences are. And in fact, there should be symbolic ways of teaching preferences as against pairwise comparisons over behaviors. In fact, it's extremely hard to show pairwise behavior patterns if you're asking about what future you would like, because how do I show you two possible videos, unless I'm Christopher Nolan or something, of two possible behaviors so that you can say up and down. And that's like a $3 billion per, like a $300 million per example. That's a very slow way to teach things.
Yeah, I want to definitely second that. I heard someone describe RLHF as like a big adversarial attack on human cognition, right? It's and I can attest to this, right? So I was trying to test, can ChatGPT do logical reasoning? I write down a little logic puzzle and I get an answer, and I have to look at it for 15 minutes to figure out where the mistake is. And the mistake is there, but it's just like, it's so well written, so seemingly obvious, so much of it is right, that it's really, what we're essentially doing right now is we're teaching these models not to do the right thing, but to generate something that within bounded rationality of our brain is just indistinguishable from truth. And that's just very dangerous, of course, right? And so, yeah, I just want to second that.
Yeah, also I was curious also, I think one of the I also 100% agree, and I think that even just, eliciting much more high-dimensional information about how to do better or what to do better seems like an obvious thing that we should be doing. I'm curious also about whether it feels like a potential application for some of these language models are like things like tutors, right? Like to help students actually understand things. I'm curious whether that could be a sort of interesting forcing function to ensure that, like, okay, your students have to do well, like they actually have to understand the problem you're trying to explain. I'm curious whether there's a way that you can, like, that's a place where if you gave the wrong sort of reasoning or the wrong kind of explanation, there's a clear way that the student didn't actually understand what was happening because you made up an explanation. Again, many open questions on how you'd actually train this tutor to be better, but just maybe developing ways in which there is a way in which this just as a brainstorm of, like, what are ways in which we can actually make sure that the explanation, there's some way that there's a cost for the explanation being poor. And I think that, at least from my personal experience, one of the ways that I find out whether I understood something is by trying to explain it to someone else. So and if they understand it, then that means that my explanation was reasonable.
I want to go back to the term transparency. And I think the first step, we should, again, talk about the data. If we don't know what's in the model, it's going to be hard to be transparent. So I think we should push all these providers of models to be much more transparent, and I don't think they will do it unless there is an incentive. So we have a wrong incentive structure today where we can use a model and make money with it without revealing a lot of what's in the model, and it's okay if it says wrong things, and it's okay if people are harmed with this. So I think if we had the right incentive, the right research would happen. Today, the research that happens is more there to make more money.
So I think it's more of like a comment which I don't have like decisive answers for. So I think when we talk about explainability of language models, it's also worth thinking about is generated explanation an explanation. So if it is what the language model generates, that is what it's thinking. So it might not be the actual process it's using to make the decision. So it's very interesting to maybe somehow characterize the correlation between what's generated versus what's the actual reasoning process happening in the language model.
So two things. One is back to the beginning part where Guy was talking about the form versus content. I do think that ultimately is something that we should all keep in mind when you do RLHF on LLM. You're just making it say things that are in the right form, more right form, not necessarily that it's correct, in the sense that there's no guarantee that they'll be correct. And if you know the answer, of course, I mean, then you know the answer and what exactly is the LLM doing. And I actually think that the whole angst about English teachers being extremely worried that LLMs are going to make English teaching extremely hard is really a joke on them, because they, along with all of us, have always conflated good form with good content. And now form is always available. Like, you know, you will get very compelling sounding explanation that's just bogus, okay? And the only place where you would not, Guy would not have to spend 5.5 hours trying to figure out where exactly is it wrong, is if in fact there are automated interpreters and the error is actually in syntax, not in logic. That's basically what is happening in Code Assistant and Copilot, and that's why actually it's a useful thing. It comes up with something, and if it makes a mistake, hopefully if it makes a syntactic mistake, I'll catch it. If it makes a semantic mistake, I don't know if Swarath is here. I think he tweeted the other day that it came up with this wrong code that took him like 4 hours to fix. And that's basically what would happen. And I also want to add a second thing, which is the one positive thing I'll say about LLM. I actually think we should not, if I'm talking right now, you don't ask me, Rao, where all did you train yourself on? What are all the data you trained yourself on? I did go to, grade schools, and I teach in grade schools, etc. But, you don't really know what all I read on the way to here. We don't ask each other what data we trained ourselves on, so we shouldn't necessarily depend on figuring out what data LLMs are trained on. And even if they were to tell you, if they were to say, this is the 600 gigabytes of data that we trained on, who the heck is going to be able to figure out whether or not the answer is either there or one step away reasoning there or 2 steps away reasoning there? We shouldn't base our research, at least, on whether or not the data has been made public. They're basically saying we're using more or less the entire web, and that's fine. The joke is on us if we basically assume that when it gives the right answer, we give it full points, and it gives the wrong answer, we keep prodding it until it gives the right answer and it becomes correct. And as I was saying in my talk, if we go with that, I have a great scientific discipline called astrology that works extremely well, in the sense the believers basically give it full points when it actually winds up, the prediction winds up being right, and when it becomes wrong, they say, oh, no, we'll forget about that. And if you do that, then LLMs are indeed reasoning, and so that's our problem, not whether or not we know the data.
Maybe I can add perhaps a boring technical point, but something that really bothers me is that we treat these models as just outputting one piece of text. And it's kind of like going to Las Vegas and playing the slot machine over and over and over again. And then one time you make a profit, and then you conclude, oh, this machine gives me profit, I should keep doing this. Right? So what's really going on is that there's probability distribution behind this model, and we should, if we talk about transparency, we should understand what this distribution is. And some of it is horrible, some of it is correct, some of it is right. And just by keeping sampling from this model, we will never really understand what it really is, because it's more than one sample. And it's weird to talk about understanding distributions, but we should have tools that really go towards not just single sample and begging over and over again until we get something we like.
Well, thank you so much for all your thoughts. This concludes our panel, so let's thank the panelists.